J here. We are going to continue the topic matrices, and from our previous lesson there are some assignment I gave you on multiplication and addition of matrices. We are going to start with that. So here was the assignment. The assignment was that given that P, so you were told that matrix P equals negative 2, negative 3, 4, negative 6, and then you've been given matrix R, which you've been told equals, matrix R equals negative 2, negative 3, 4, then negative 6. Now, then you are told, using that information, you are told to work out the value of M. So we have, they want us to get the matrix M, given that M equals 2 over 3 matrix P minus matrix P R. Now, in this specific scenario, first of all, we are going to start by multiplying the first one. So I'm going to come here. Let me replace the value of P and R. So let me first of all get the first matrix, which is 2 over 3 P. So 2 over 3 P, this one is going to be the same as 2 over 3 into the matrix negative 2, negative 3, 4, negative 6. Whereby I'll multiply there. 2 over 3 multiplied by negative 2, I'll have there negative 4. Negative 4 over 3. Then 2 over 3 multiplied by negative 3, I'll have there negative 2. Then 2 over 3 multiplied by 4, I will have here 8 over 3. Then 2 over 3 multiplied by negative 6, that is going to be 2 goes into 3 goes into negative 6, negative 2 times negative 2 multiplied by 2, that I'm going to have as negative 4. So this one is my 2 over 3 P. So here we've already gotten 2 over 3 P. Let us now get PR. PR means that we are going to multiply P and R. So let us multiply P and R. I'm going to have here P is negative 2, negative 3, that is 4, negative 6, then multiplied by negative 2, negative 3, 4, negative 6. Now, remember in our previous lesson, I said that whenever you will be multiplying matrices, you have to consider the row and the column. You have to consider the row and the column. When you're going downwards, this one is the column. This one is the column. When you're going sideways, this one is the row. So in this case, remember, now here, if I want to multiply, remember I told you that on the first matrix, consider the row. Multiply your row, the first row, with both the columns before you continue with the second row. So let us begin. To start with, I'm going to come here, say negative 2 multiplied by negative 2 multiplied by negative 2, that is going to be 4. Then negative 3 multiplied by 4. So I'm going this way and downwards like this with the first one. So negative 2 multiplied by negative 2, that one is 4. Negative 3 multiplied by 4, that is going to be negative 12. So plus negative 12. Then we go to the second column on the other side and the first row. Remember, you have to multiply this first row with both the columns of the other matrix. So I'm going to have here negative 2 multiplied by negative 3, that is going to be 6. Then we're going to have here negative 3 multiplied by negative 6, that is going to be 18. So plus 18. Then now we go to the downer row for the first matrix, and then you multiply it with both the column of the second matrix, which means I'm going to come here, say this 4 multiplied by this 4, I'm going to have here 16 plus this 4 multiplied by negative 2, 4 multiplied by negative 2, I'm going to have negative 8, then plus negative 6 multiplied by 4, that is going to be negative 24. So negative 24. I'm done with the second row with the first column for the second matrix. Then I'm going to go with the second row and the second column for the first matrix, for the second matrix. So I'm going to have here 4 multiplied by negative 3. I'm going to have there negative 12 plus then negative 6 multiplied by negative 6, which is going to be 36. Then now I'm going to combine them using an addition. That is going to be 4 plus negative 12. That is going to be negative 8. Then 6 plus 18. That is going to be 24. Then negative 8 plus negative 24. That is going to be negative 32. Then negative 12 plus 36. That is going to be, I think it's going to be 24. So it means that my PR is going to be that. And remember, you are told the value of M. M equals what? M equals 2 over 3P, of which we got 2 over 3P to be negative 4 over 3, negative 4 over 3, negative 2, 8 over 3, then negative 4. Then it was a minus PR. This is my PR. I'm going to have there negative 8, 24, negative 32, 24. Then I'm going to combine them. What am I going to have here? Negative 4 over 3 minus negative 8. So here, I'll have to do it here. That is negative 4 over 3, negative 4 over 3. Now that is going to be a plus because this minus and this minus forms a plus. Remember I said whenever you're adding or subtracting matrices, you have to consider the position of each number in those matrices. So because negative 4 over 3 is in the same position as negative 8, we are going to combine them with that minus. So negative 4 over 3 minus minus is going to be a plus 8, whereby we are going to have 20 over 3. So for the first one, we're going to have 20 over 3. Then negative 2, negative 24, that is going to be negative 26. Negative 2 and 24 are on the same position on those two different matrices. So you're going to combine negative 2 and 24 using that negative. Then we are going to have here 8 over 3 minus negative 32. That is like a plus. So let us combine it. That is 8 over 3. 8 over 3. 8 over 3 minus 32. Minus, that one is a plus. So minus 32, we are going to have 104 over 3. So 104 over 3. And then finally, negative 4, negative 24, we are going to have negative 28. And that is our answer for the value of P. So that is the value of M because we were told to get M. So M equals 20 over 3, negative 26, 104 over 3, then negative 28. So we are going to have a small break, then we'll come back for the next session. So welcome back. We continue with the topic matrices. Now, next, I want us now to look at inverse of a matrix. Inverse of a matrix. Now, what do we mean by the term inverse? Inverse, it means that you're getting the opposite of what you're having. The opposite of what you're having. When you talk about an inverse, is the opposite of what you're having. So whenever we'll be talking about inverse of a matrix, it's as if we'll be getting the opposite of the matrix that we are having. So now, before you even start calculating the inverse of a matrix, there are certain things you have to know about calculation of an inverse. Now, suppose I have a matrix A, B, C, D. This one, I'm going to use it to represent my matrix. Now, if I want to get the inverse of that matrix, the very, very first thing I have to know is how to get the determinant. the determinant. And how do you get the determinant? Now, before we get the determinant, I want us to name those diagonals. Now, here we have the diagonals. Now, this diagonal, that diagonal, which is slanting towards your right, it is usually called the lead diagonal. This one is called the lead diagonal. That is called the lead diagonal. Then this other diagonal that is slanting away from your right hand side, or this one is slanting towards your left hand side. The one that is slanting towards your right hand side, it is called the end diagonal. This one is called the end diagonal. So whenever you want to get the determinant, you usually multiply, or you get the product of the lead diagonal multiplied by the product of the product of lead diagonal. You get the difference between the product of the lead diagonal and the end diagonal. So it means that for me to get the determinant, I'm going to take the lead diagonal, which is AB. The product of the lead diagonal, you get the difference from the product of the end diagonal, that is CB. And by doing that, I'll have my determinant. Once you've identified the determinant, now this is now where the inverse now begins with. You are going to get the inverse of that determinant, whereby the inverse of the determinant is going to be 1 over the difference of the product of the lead diagonal and the end diagonal, which means I'm going to have here 1 over AB minus CB. By doing that, I've gotten the inverse of the determinant. Once I've gotten the inverse of the determinant, now I'm going to come to my matrix, whereby remember our matrix is still A, B, C, D. Now, with this, you have to know that with the lead diagonal, with the lead diagonal, you are going to change the position of those values. So this one, we are going to change the position. So change the position, which means where the A is and the D is, I'm going to change their position, which means D is going to occupy where A was and A is going to occupy where D was. We are going to change their position. Then to my end diagonal, I'm going to change the sign. I'm going to change the sign, which means if B was a negative, it is going to be a positive. If it was a positive, it is going to be a negative. My C, if it was a positive, it is going to be a negative. If it is a negative, it is going to be a positive. So you change the sign of the end diagonal and the position of the lead diagonal. By doing so, you will have gotten the inverse of that matrix. Now, the general inverse, which means to get the inverse of this matrix now, I'm going to have something like this. Remember, for the lead diagonal, they change their position. So I'm going to have there D, negative B, then negative C, A. So that is the inverse of my matrix. Once I've done that, I'm now going to multiply the inverse of my determinant with the inverse of the matrix, which means I'm going to have 1 over AB minus CB multiplied by the matrix D minus B minus C A. So that is going to be my general formula for getting the determinant. Now, I want us to try some example. Let's say for instance, given a matrix maybe 4, 5, 6, 3. I've been told to get the inverse of that matrix. How am I going to get the inverse of that matrix? Remember, you have to get first of all the determinant. Let us get the determinant. So in this case, I'm going to get the determinant, whereby the determinant, remember I've said, determinant is the difference between the product of the lead diagonal and the end diagonal. So let us first of all start with the product of the lead diagonal, which is 4 and 3. I'm going to have there 4 multiplied by 3 minus the product of the end diagonal, whereby I'm going to have 5 multiplied by 6. which means what am I going to have? I'm going to have here 4 multiplied by 3, that is going to be 12, minus 5 multiplied by 6, that is going to be 30. Which means what am I going to have as my determinant? I'm going to have my determinant to be negative 18. That is going to be my determinant. Remember, once you've gotten your determinant, you are going to get the inverse of your determinant. That is the reciprocal, that is. So you're going to get the reciprocal of your determinant, whereby negative 18, the inverse of negative 18 is going to be negative 1 over 18. And there I have the inverse of my determinant. Number 2, I'm going to get the inverse of the matrix. Whereby, how am I going to get the inverse of the matrix? Number 1, you have to know that for the lead diagonal, you are going to change the position, while for the end diagonal, you are going to change the signs. So in this case, my lead diagonal is 4 and 3. They will change their position, whereby I'm going to have now here 3. This one, remember, it is going to change the sign. Because it is a positive, it is going to be a negative 5. This one is going to change the sign. Because it is positive 6, it is going to be negative 6. This one, it is going to be, instead of 3, remember they did change the sign, the lead diagonal, so I'm going to have there 4 instead. And that is the inverse of my matrix. Then, now let me combine the two. Now for me to combine the two, I'm going to come and say negative 1 over 18, then now multiply with the inverse of the matrix, which is 3, negative 5, negative 6, 4. Whereby what am I going to have? Negative 1 over 18 multiplied by 3. 3 goes there 6 times, so I'm going to have here negative 1 over 6. That is for that. Then that one, I'm going to have this negative and this negative will form a positive. So I'll have here 5 over 18. Then negative 1 over 18 multiplied by negative 6. It is going to be what? We are going to have there, that 6 goes into 18 how many times? 3 times. So we are going to have 1 over 3. Then 4 multiplied by that, we are going to have there 9, 2. So I'm going to have there negative 2 over 9. So this one is our inverse. Now, there's something interesting you're going to notice. And I want us to do it together. I want us to do it practically. Now, what will happen if I decide to multiply the inverse of the matrix and the original matrix? What is going to happen? Let us try that. We are going to try it together. Let us try it here. So, the original matrix was 4, 5, 6, 3. And then I want to multiply it with the inverse, which is negative 1 over 6, 5 over 18, 1 over 3, then negative 2 over 9. Now, I want us to multiply that. Now, when I multiply that, remember, during multiplication, we said that you have to consider the row and the column. And I said that for the first matrix, consider the row. For the second matrix, consider the column. So it means that I'm going to multiply this row with both the columns before I come to the second row. So let us do that. Let us start. 4 multiplied by negative 1 over 6. I'm going to have there, it is going to be negative 2 over 3. So I'm going to write it here. Negative 2 over 3 plus 5 multiplied by 1 over 3, which means I'm going to have there 5 over 3. That one I'm done with the first row and the first column. I'm going to go to the first row and the second column. So 4 multiplied by 5 over 18. That is going to be 4, that is 2, that is 9, that is 10 over 9. So 10 over 9 plus 5 multiplied by negative 2 over 9. That is going to be negative 10 over 9. Negative 10 over 9. Then now let us go to the second row, the first column and the second column. So I start 6 multiplied by negative 1 over 6. That is going to be negative 1 plus 3 multiply by 1 over 3. That is going to be 1. Then next, 6 multiply by 5 over 18. 6 goes there 3 times. So I'm going to have 5 over 3. 5 over 3 plus. Then 3 multiplied by negative 2 over 9. 3 goes here 3 times. So I'm going to have here negative 2 over 3. It is going to be negative, let me see. 3 goes here, 3 goes here 3 times, here 1, 3 times, yeah, negative 2 over 3. Now, that is what I'm having. Now, let us now combine them the way we were combining under multiplication. Negative 2 over 3 plus 5 over 3. Negative 2 over 3 plus 5 over 3. I'm going to have there 3 over 3, which is equivalent to 1. 10 over 9 plus minus 10 over 9, that is going to be 0. Negative 1 plus 1, that is going to be 0. Then 5 over 3 plus negative 2 over 3, that is going to be 3 over 3, which is going to be 1. Which is going to be 1. So that whenever you multiply a matrix and its inverse, the answer should always be 1, 0, 0, 1. That is always the what? That is always the answer. So whenever you realize that you're multiplying a matrix with its inverse, automatically know that the answer is going to be that. It is going to be 1, 0, 0, 1. So don't really bother about doing a lot there. So that is how we get the inverse of a matrix. Let us try another example. Let's say, for instance, you're being told, find inverse of, let's say, for instance, you have negative 3, negative 2, 7, negative 9. That one. Now, what is going to be the inverse there? Now, the very, very first thing you have to know, remember we've said that, first of all, you have to get the determinant. Let us get the determinant here. Remember determinant, we said, determinant is the difference of the lead diagonal, the difference of the product of the lead diagonal and the end diagonal. In my case here, the lead diagonal is going to be negative 3 multiplied by negative 9. So I'm going to have there negative 3 multiplied by negative 9, subtract the end diagonal, which is going to be 7 multiplied by negative 2. Which means what am I going to have there? Negative 3 multiplied by negative 27, that is going to, negative 9, that is going to be 27, minus 9 multiplied by negative 2, that is going to be negative 14. That is going to be negative 14. We're going to have quite a very huge value of the determinant, whereby it is going to be 27 plus 14. That is going to be, that is 37, that is going to be 41. 41. That is our determinant. Then, let us get the inverse of the determinant. The inverse of this determinant, we are going to have it as 1 over 41. Remember, I've told you that the inverse of a determinant is just like getting the reciprocal of that determinant. Once we've gotten the inverse of the determinant, let us now get the inverse of the matrix. Now, my matrix is that. Remember we said, for the lead diagonal, the position changes, while for the end diagonal, the sign changes. So in this case, this one being my lead diagonal, the inverse is going to change. The position is going to change, which means I'm going to have here negative 9, and this one end diagonal, their sign is going to change. So instead of having here negative 2, I'm going to have positive 2. Instead of having here positive 7, I'm going to have there negative 7. Then there I'm going to have negative 3, because the position of negative 3 and negative 9 have changed, while the sign of 2 and 7 also have changed. Then what am I going to do? I'm going to take the determinant, I multiply it by my my inverse of the matrix, which means I'm going to have here 1 over 41 multiplied by what? Multiplied by negative 9 to negative 7, negative 3. Which means I'm going to have my inverse as 1 over 41 multiplied by negative 9. I'm going to have there negative 9 over 41. Then 1 over 41 multiplied by 2, I'm going to have there 2 over 41. Then I'm going to have here 1 over 41 multiplied by 7. I'm going to have there negative 7 over 41. Then I'm going to have here 1 over 41 multiplied by negative 3. I'm going to have there negative 3 over 41. And that is my inverse of that matrix. Suppose I was told to multiply this inverse of that matrix and its actual matrix, I know that the answer is going to be 0, 1, 1, 0. And that is how we get the inverse of a matrix. Now, an NB. In some instances, you're going to realize that there are so NB, we are going to say here. Now, sometimes you can find that you've been given a matrix and you realize that the inverse of this matrix is 0. Or when the matrix the determinant is 0, we talk about that matrix do not have a determinant. So an NB here, we are going to say a matrix whose inverse is 0 is called a singular matrix. Now, in most cases, if the examiner tells you that a certain matrix is a singular matrix, you have to know that the determinant of that matrix is 0. The determinant of that matrix is 0. A matrix whose inverse is 0 is called a singular matrix, or it doesn't have a determinant. So that one we call it a singular matrix. Let us try maybe an example of application of that specific phenomena. We can have this being told the matrix M equals K, then K plus 3, 1, and then 2K. You're being told that matrix has no inverse. Then you're being told determine the possible values of K. Determine the possible values of K. Now, how are you going to get the value of K? Remember, you've been told in that instance, matrix M do not have an inverse. Now, remember I've said, if a matrix does not have an inverse, we call it a singular matrix. And in this case, because this matrix is a singular matrix, it means that the determinant is 0. That is one of the things you have to know about a singular matrix. Determinant is 0. Determinant equals 0. So let us get the determinant of that matrix. So remember we said that the determinant of a matrix, we get it by getting the difference of the product of the end matrix and the leading matrix and the end matrix. In my case here, determinant is going to be what? Determinant is going to be the lead matrix, which is K multiplied by 2K, then subtract the end matrix, which is 1 multiplied by K plus 3. That is how we are going to get the what? The expression for the determinant, which means I'm going to have here K multiplied by 2K, that is going to be 2K squared, minus, that is going to be K, minus negative 3, that is going to be negative 3 there. So instead of having here a positive, we are going to have a negative, because this negative multiplied by this positive is going to give you a negative. Remember, we said that the determinant of a singular matrix is 0. So it means that in this case, 2K squared minus K minus 3 equals 0. This one is a quadratic equation, because remember, a quadratic equation is usually in form of ax squared plus bx plus c equals 0, whereby a, b, and c are constants. So this one is a quadratic equation. We have 3 ways in which you can solve quadratic equation. We have the quadratic equation formula, we have the completing square method, and then we have the factorization method. In my case here, I'm going to apply the factorization method. Under factorization method, we are going to get the product and the sum. Now, what is the product in this specific case? If you want to get the product, you take the first value, you multiply it with the last value, including the signs. So in this case, for me to get the product, I'm going to say 2 multiplied by -3, I'll get there -6. And what is the sum? The sum, this middle number is usually the sum, which is, in my case here, it is -1. You don't always include the algebraic expression, that is the k. So in this case, I'm going to have, what are the two numbers? If I multiply them, I get -6. If I add them, I get -1. Which are those two numbers? So I know it lies between 3 and 2. So how can I make 3 and 2 to give me -1? I can have maybe -3 and 2. -3 and 2. Because if I take -3 multiplied by 2, I get -6. If I take -3 plus 2, I get -1. So those are my product and the sum. I'm going to substitute them where there was the sum. So instead of having here -k, I'll have here 2k squared. So instead of having that k, I'm going to have here -3 and the k, then plus 2 and the k, then -3 equals 0. Then what am I going to do? I'm going to pair. You pair them like that. And in each pair, you look for a common factor. In this case, the common factor in the first pair is going to be k. It is going to be k. So I'm going to have there k into, k goes there 2k, then -3. Because k going to 3k 3 times. Then we are going to have here plus, then here common factor is 1. 1 into 2k -3. There has to be a common factor in both brackets. Let me get the value of k. I'm going to take one of the common expressions there, which means I'm going to have here 2k -3. Remember, this was equated to 0. And then I'm going to take that and combine it so that I can have there k plus 1, which is equal 0. I can get the value of k, which means I'll start with the first one, which is 2k -3 equals 0. I'll take 3 to the other side, it will be a positive. I'll have here 2k equals +3 over 2 over 2. So the first value of k is 3 over 2, or the second value of k, I'm going to have there k plus 1 equals 0. Take 1 to the other side, I'll have here k equals 1. So the value of k is either, this one is going to be 3. So it is going to be k equals 3 over 2 or -1. And that is going to be the what? That is going to be the value of k. So that is the application of the specific, information right there. A matrix whose inverse is 0 or a matrix with no inverse is called a singular matrix, and you have to know that that matrix do not have a determinant, or the determinant is 0. So whenever you've been given those expressions, you'll have first of all to get the determinant. Then the expression of the determinant you get, you're going to equate it to 0 and solve for the unknown to get the value of the number that you are being asked there. So we will come back after a short break and look at application now of inverses in solving maybe simultaneous equation. So, welcome back. Now we are going to look at solving a simultaneous equation using matrix. Using matrix method, we are going to solve a simultaneous equation. Now, under this, you have to know that simultaneous equation, there are other methods that are involved in solving it. We have a method called substitution method. We also have another method called elimination method. So in this case, we are going to use the matrix method to solve a simultaneous equation, highly examinable area. So we have this example. We're going to try out this example together. You're being told find the inverse of matrix. So here you're being told find inverse of matrix. Find the inverse of matrix 3, 1, 2, -1. 3, 1, 2, -1. So first of all, let us get the inverse of that matrix. Yeah, we've seen how to get the inverse of a matrix. Number one, remember I said you have to get the determinant. And remember, I said that the determinant is the product of the lead diagonal minus the product of the end diagonal. In my case here, the lead diagonal is going to be 3 multiplied by -1, then minus the end diagonal is going to be 1. So, what is going to be our determinant here? We are going to have our determinant as 3 multiplied by -1, that is going to be -3, minus 1 multiplied by 2, we are going to have there 2. So it means that my determinant here is going to be -3 multiplied by -3, -2, it is going to be -5. And then I'm going to get the inverse of my determinant, whereby the inverse of my determinant is going to be -1/5. Once we've gotten the inverse of the determinant, I'm going to take the inverse of the determinant, which is 1/5. I multiply it with the inverse of the matrix. And how do we get the inverse of the matrix? If you want to get the inverse of the matrix, you are going to change the position of the lead diagonal and the sign of the end diagonal. So the inverse of that matrix, I'm going to have it as -1, 2, -1, -1, because you have to change the sign for this one. Then -2, because it is +2, so it is going to be -2, and then 3. So you have to remember always to change the position of the lead diagonal and the sign for the end diagonal, whereby if I multiply that, I'm going to have -1/5 multiplied by -1. I'm going to have there 1/5. Then -1/5 multiplied by -1, I'm going to have there also 1/5. Then -1/5 multiplied by -2, I'm going to have there 2/5. Then -1/5 multiplied by 3, I'm going to have there -3/5. And that is the what? That is my inverse. That is my inverse. The second part of that question, you're being asked. And the second part of that question, you're being asked, hence, find the coordinate of the points of intersection of line 3x plus y equals 4. So we have line, that is the inverse of the matrix. So using that inverse, we are being told to solve this equation. You're being told, hence, find the coordinate of the point of intersection. You know that if you want to get the coordinates of the point of intersection, you usually solve those two equations simultaneously. So the two equations we are going to be given here, we are going to solve them simultaneously, whereby we are going to solve them, they are going to be simultaneous equations where we are going to use the matrix method. So the equations are 3x plus y equals 4, 3x plus y equals 4, 3x plus y equals 4, and then we have 2x minus y, 2x minus y equals 2x minus y equals 1. So that is an example of a simultaneous equation. How are we going to solve it using the matrix method? Number one thing, you have to form a matrix from it. And for you to form a matrix, first of all, you're going to take the numbers. For the 3x, I'm only going to take 3. For the y, that is +1. For the 2x, I'm only going to take 2. And then for the y, I'm going to take, because it is a negative, I'm going to have there -1. So this is my matrix. Then the first letter usually begins at the top. The second letter is usually at the bottom. So we're going to have there xy being equals to what? Being equals to 4, 1. So in some scenario, the examiner might tell you to form a matrix equation using the information given. So this is going to be my matrix equation. Using this matrix equation, I'm going to solve the value of x and y. And what am I going to do? I'm going to multiply both sides by the inverse of the matrix, which means I'm going to come here, say 3, 1, 2, -1. I'm going to multiply it by the matrix, the inverse, which is 1/5, 1/5, also 1/5 there. Then 2/5, 2/5, -3/5. Then x, y, being equals to. Now, in most cases, under simultaneous equation, whenever you're multiplying that, remember you have to multiply this side of the equal sign. The left-hand side of your equal sign, you have to multiply with the inverse. Also, the right-hand side of the equal sign, you have to multiply with the inverse. I usually advise students, whenever you want to multiply with the inverse, on the other side, always first of all write the inverse of the matrix. It will be much easier to multiply first of all with the inverse than the matrix that you had on the other side. So the inverse, I'm going to have here 1 over 5, 1 over 5, 2 over 5, negative 3 over 5. Then multiply by this matrix, which is 4, 1. 4, 1. Now, what do you remember? In our previous session, we said that if you multiply a matrix by its inverse, you are going to get a 0, 1, 1, 0 matrix. Let me write it here. So you're going to get a 0, 1, 1, 0, 1, 0, 0, 1, 0, 1, 1, 0. All of them are the same. So whatever we have there is the same as 1, 0, 0, 1. It is the same. So 0, 1, 1, 0. When you multiply a matrix and its inverse, you're going to get 0, 1, 1, 0. Then I'm going to have matrix X, Y for the letters equals. Now on the other side, now you're going to multiply. Remember, when multiplying, you have to consider the row and the column. So remember, when you were multiplying, I said that you start on the first matrix, you start with the row, you multiply with the column for the other matrix. So let us start. 1 over 5 multiplied by 4, I'm going to have 4 over 5. Plus 1 over 5 multiplied by 1, I'm going to have there 1 over 5. I'm done with the top one. Let me go to the lower row. I multiply with the whole of that column because it is only one column. 2 over 5 multiply by 4. I'm going to have 8 over 5 plus negative 3 over 5 multiplied by 1 is going to be negative 3 over 5. Which means what am I going to have? I'll have here 0, 1, 1, 0, x, y, being equals to what? Being equals to 4 over 5 plus 1 over 5. That is going to be 5 over 5. 5 over 5, that is 1. Then on the denominator, we are going to have 8 over 5 plus negative 3 over 5. That is going to be 5 over 5, which is also going to be 1. So it means that the coordinate of the point of intersection is going to be x equals 1. So here, this one is like x equals 1 and also y equals 1. So it means that the coordinate of the point of intersection is going to be 1, 1. This is the coordinate. Coordinate of point of intersection. Point of intersection. So let us try another example. Now this example, you're being told matrix P is given by 4, 7, 5, 8. Then question number 8, you're being told to find the inverse. When it has been written as P negative raised to power negative, that one is an inverse. So you're being told you find the inverse of P. Then question number P, you're being told two institutions, Katulani High School and Ntia High School, purchased beans at B shillings per bag and maize at shillings M per bag. Kitulani purchased 8 bags of beans and 14 bags of maize for 47,600. Ntia purchased 10 bags of beans and 16 bags of maize for 57,400 shillings. Form a matrix equation to represent the information above. Yeah, that is the question that I was telling you about. Then question Roman 2, you're being told use matrix inverse to find the prices of one bag of each item. Number C, you're being told the price of beans later went up by 5% and the maize remained constant. Katulani bought the same quality of beans but spent the same total of money as before as two items. On the two items, state the new ratio of beans and maize. So let us begin. So first of all, question number A. question number A, you're being told to find the inverse. So the matrix that you've been given matrix P, which is 4, 7, 5, 8. 4, 7, 5, 8. Then you're being told to get the inverse, the inverse. That is the sign for the inverse. Now, how do we get the inverse? First of all, remember you have to get the determinant. Let us get the determinant. So determinant equals to the difference between the product of the lead diagonals and the product of the end diagonal. So let us get the product of the lead diagonal is going to be 4 multiplied by 8, while the end diagonal is going to be 7 multiplied by 5, which means I'm going to have there is going to be 32 minus 35, which means my inverse here, the determinant is going to be -3, whereby the inverse of my determinant is going to be -1/3. Once I've gotten that, I'm going to multiply that inverse of the determinant with the inverse of the matrix. So the inverse of this matrix, which means I'm going, first of all, remember you change the position of the lead diagonal. So if here I'm having 4 and here I'm having 8, which means they are going to change their position. I'm going to have their 8. Then if here I'm having +7, we are going to change the sign for the end diagonal. So it means that instead of 7, I'm going to have their -7. Instead of 5 here, I'm going to have their -5. Instead of 8, I'm going to have their 4. So I've changed the position for the lead diagonal and the sign for the end diagonal. Then let us now multiply them to get our inverse. -1/3 multiplied by 8, I'm going to have -8/3. Then -1/3 multiplied by -7, I'm going to have 7/3. Then -1/3 multiplied by -5, I'm going to have 5/3. Then 5/3. Then -1/3 multiplied by 4, I'm going to have there -4/3. That is going to be my what? That is going to be my inverse. That is question number A. Question number B. Question number B, Roman 1. Question number B, Roman 1, you are told that two institutions, that is Kitulani High School and Nthia High School, purchased beans worth shillings B per bag and maize worth shillings M per bag. Kitulani purchased 8 bags of beans. So 8 bags of beans and what? 8 bags of beans and 8 bags of beans and 14 bags of maize. 14 bags of maize at 14 bags of maize at 47,600. 47,600. And then this other school, that is Nthia, purchased 10 bags of beans. So 10 bags of beans and 16 bags of maize at 57,400. 57,400. Then you're being told to form a matrix equation. Now, first of all, I have to make sure that the matrix equation I form here should be similar to the one that is here. So it means that I'm going to simplify where possible. I'm going to simplify where possible. Let me have this one down here. Let me have a 10b plus it was 10b and 16m. 16m equals 57,400. Now, first of all, I look at my first equation. Can I simplify that? Can I simplify that for the top here to have here 4 and here 7? Yes, I can divide by 2. So I'm going to divide there by 2, divide there by 2, divide there by 2. And also this one, can I simplify to have here 5 and 8? Yes, also I'm going to divide there by 2, divide there by 2, divide there by 2. Which means the equations that I'm going to have here, let me write them here. I'm going to have here 4b plus 7m. 7m equals, that is going to be 2, 3 into 16, 8, and then 0, 0. For the second one, I'm going to have there 5b plus 8m, which is going to be what? Which is going to be, that is going to be, 2 goes there how many times? 2 goes there 2 into 17, 8 into 14, 7, then 0, 0. So we're going to have there 28, 700, and there we are going to have 23, 800. Remember, we were told for question Roman 1 to form a matrix equation. So the matrix equation, remember I told you come here, right? The 4, 7, 5, 8, like that. Then the first letter will be at the top, the second letter will be at the bottom, that is BM, equals what? 23, 800. Here is 28, 700. And that is the matrix equation, as simple as such. Roman 3, you're being told use the inverse of the matrix to find the prices of one bag of each item. So we want to find the price of one bag of each of the item. What are we going to do? Number 1, remember I said, so for the Roman 2 here, you are going to multiply each of the side with the inverse. So it means that I'm going to have this side, I'm going to have 4, 7, 5, 8, multiply, what was the inverse? The inverse was negative 8 over 3, negative 8 over 3, 7 over 3, then 5 over 3, then negative 4 over 3, and then here is going to be B, M. Now, whatever you do on your left-hand side, you're going to do it on the right-hand side. So on the right-hand side, remember I said, for easier multiplication of that matrix, you have to begin with the inverse. So I'm going to begin here with the inverse, which is 8 over 3, negative 8 over 3, 7 over 3, then 5 over 3, then negative 4 over 3. Then multiply by the matrix, 23, 800, then 28, 700. Let us now multiply. I know that when I multiply a matrix and its inverse, I'm going to get a 0, 1, 1, 0 matrix on that side. Here I'm going to have B, M, which is going to be equal to what? Let us multiply there. So, let us multiply. Remember, multiplication of matrices, you have to consider the row and the column. So in this case, this row, I'm going to multiply with the column, each of those columns. So let me first of all start with this first row. Negative 8 over 3 multiplied by 23, 800. Let me negative 190, negative 190, 400 over 3. That is that and that. Then this and this. 7 over 3 multiplied by that. So plus, so to have here 200, 900 over 3. Then now let us go to the downer row with all the columns. 119 that over 3. Then plus negative 4 over 3 multiplied by 28, 700. 14, negative 114, 800 over 3. That is what I'm going to have. So I'm going to have here 0, 1, 1, 0. Here I'm going to have BM being equals to what? Let us get each price of the beans and the maize. So I'll come there, 3,500, and then the lower one, 1,400. So it means that the price of beans is going to be shillings, 3,500, and the price of maize is going to be shillings, 1,400. And that is how we get the what? We get the price of the maize and the beans. That is how we get the maize and the beans. So we've solved that simultaneous equation using matrix method. We've solved that simultaneous equation using matrix method. Now, for the question number C, I'll want you to try it out on your own. Yeah, you'll try it out. Once you have the price of beans and maize, getting understanding that question and doing it is not going to be a problem. So for your assignment, I'm going to display them on the screen, so you're going to see them on the screen. You'll do them and maybe if you can share your answer through our number, which will also be displayed on the screen, our email or WhatsApp, will be much appreciated. Thank you very much. For more help, just contact us, and thank you very much. Have a good day.